Hey, welcome back. Welcome to the channel. Glad to see you again. Thanks for joining. So I gotta love some of the stuff my clients bring to me to work on. This is what makes it so interesting. Is they bring me this stuff, and this is stuff I've never seen before. This is a Rock-Ola transistor stereo amplifier. This is a 43500-A. It's a chassis amplifier. It's not meant to be used as a regular amplifier. It's specific for the jukebox, and this is for a phono jukebox. Cool, pretty cool. Okay, so he brought this to me. He says it's been recapped, but it doesn't perform like it should. It's got weak channel or weak channels, and he wants me to go over it, make sure everything's 100%. And I agreed to take this one on, even though I've never seen one of these before. I don't know anything about them, but I'm just looking at it here. It looks got these Delco GM output devices, and these scream germanium to me. So this kind of dates this. I was looking at this earlier, and I kind of love the layout. Look at this. Everything's labeled, and it's nicely... everything is perfect. Well, that switch is a little buggered. So, yeah, it's good. And then he also provided me with a schematic for this model, which is good. This is going to be helpful. Saves me from searching for it. And another thing he provided was a spare part. He wants me a spare relay because this one's smashed. The cover's smashed, but I think the relay might be okay. But we can replace that. So I was looking at this thing. It is for a phono record player because it has a magnetic preamp. And it's in self-contained box. This is to keep the hum down. And there's a little preamplifier here. Anything else? Well, here's our input, obviously. And everything's labeled. That's what I like about it. Volume control. I'm missing this. This goes off to a little circuit. Probably a resistive attenuation circuit that controls the volume. I don't have that, so I might have to rig something up for this. Switchable bass and treble controls, so you don't have any potentiometers to go dirty. Mono stereo switch, AV control, a couple nice size heat sinks. The can caps, these were been replaced. Our output here for our speakers, power transformer, and a fuse. So let's flip this over, have a look at it. We can get it all in frame. Okay, you said some recapping's been done, and I can see some caps have been put in, some new caps. Also, there's some old caps still left behind. So I see new ones. I don't know if these two are new. They look new. It's hard to tell. And then this here, we're going to have to clean this up. This is 1500 microfarad, 63 volt. There's 4 of them here. 2 of them are for power supply filtering, and 2 of them are the duty of speaker output DC blocking cap. It's got a unique output circuit, or power amplifier circuit, much like the I don't know if you remember watching the Harman Kardon SR600. It has germanium outputs, and then it has the phase inverter transformer to interstage transformer to drive these transistors. It's 2 channels, obviously, and it has kind of a built-in feature. It has these dual lamps, and these are current limiting lamps. It's kind of like a dim bulb tester, but they're placed in the circuit. They're soldered in, and it makes it good because it should be near impossible to blow this circuit up. It should never blow up on us because these lamps will take any excess voltages, and if the current goes too high, the lamp lights up. But when the current stays low, the lamps stay off, and that's when they can transfer most current. So here's these lamps here. They're dual filament, and they're wired into the power amplifier section. Power amplifier section's underneath here. There's a driver board, and then our 2 transformers. Lots of other circuits here. We got an ADC circuit and preamplifier circuit, and then we have the amplifier for the phono stage. So looking at this, I don't see anything wrong with it as I just started looking at it, but there is a problem here. I see these caps are just tacked in and they're flopping in the wind, and I'm going to have to get a terminal strip in here and redo this because this is unacceptable. Eventually the wires will break, and with vibration. And plus I see they used, whoever did this, used the terminals from the old capacitors as a terminal lug, and there's still resistors, active components connected to them. So we're going to have to isolate those old capacitors and mount a terminal strip in here somewhere so that we can properly mount these caps and wire it all in so it works and it's going to be reliable. So I'll probably start with that first. It's going to be interesting working on this thing. Another thing I'm going to have to keep an eye out for is resistors. It has all these carbon comp resistors. These are 5%. And I already checked a couple of them, and there's already a few that I checked were outside of the 5% tolerance. So they're going to have to go, and we'll go through all this and make sure it's all 100% before we give it back to them. This thing's kind of cool. Raytheon resistor. Here, I'll zoom in on it. It's a resistor by Raytheon, and what it is, it's a little lamp inside there. I don't know if you can see the diagram. And then there's two photoresistors. So that's what this is. It's kind of like a crude optocoupler, but it uses incandescent lamp. I think I can unplug it. It's got its own socket. $6735. That's probably a date code. Pretty cool. You don't see this stuff very often. So yeah, I'll go through. He says it like he says. It says it works, it just doesn't work good. So we're going to try and figure out what's wrong with it. And I think I can already see something here. There's a resistor down. There's a 2-watt resistor under here. It looks like it's pretty much cooked. 470 ohms, I think. I'm not sure. It's seen a lot of heat. And here's a broken resistor. You can't see it, but it is under there. If you can see this, let me get this out of the way. Right here. See, there's part of it. Burned up resistor. So there's something going on here, and we'll have to address that. Alright, so I'm just getting into disassembly here. Made sure I took digital photos of all the boards and the wires going to it. You gotta be careful because there are wires that have the same color, yellow with a red stripe. There's two of them, so you gotta make sure you mark those, which one goes where. And I can remove these boards. I'll go over these. I'll clean them and make sure that they're all 100%. Make sure the caps are in the right way. Check all the resistors. And I'll probably even, these mylar, or these film caps here, I think I might just pull them out and test them just to make sure that they're all good. Probably are. Looks like we got silicon transistors 2N3417. And the drivers are 2N3405s. Here's what the power amplifier looks like, all the resistors and the wiring for it. It's a rat's nest, that's why you got to take pictures. And yeah, you want to make sure you don't miswire it when you put it back together. Here's another board I got loose, and the stuff going on underneath. There's circuits built under here. Here's that resistor that's blown open. You can see that. There's a resistor here that's smoked. It's like maybe it's a 22 ohm or something. And then the one below it looks, might be alright. Just got a little bit of smoke damage. So yeah, I'm just going to continue on. Here's that broken switch. And that comes from here. So that switch should actually be removed before you pull this board, but for some reason it's not like that. Okay, so I'm going to start on these circuits, on these two cards here, start on these first, and then I'll pick back up again. Okay, already running into problems here. So what I started doing is I lift the leg of every resistor, and that way I can get an accurate measurement of its value. And if it tests out of tolerance, it's going to get replaced. I have these 1 watt modern resistors I'm placing in their place. This one, for example, tested fine, so it goes back down in the hole and solder back up. So that's what I'm doing with the resistors. I have found this transistor completely open, and that is the driver for one of the channels. And this is running Class A operation, a 2N3405. Now I think this is just a Class A amplifier, 24 volts or so, and that's what it's operating on. And all it does is it drives this primary of the transformer. So I don't know if I have a 2N3405. If I do, I'll replace it. If I don't, I'm going to have to get something modern. And I think it's not very critical application. As long as it's able to do Class A with 25 volts, I'm pretty happy with what can put in here. I can calculate the current through it and stuff, but these transistors don't look to be too robust. A little bit heat sinking on them, but I'll get something to replace that transistor. The other three tested fine. The caps look like they're installed fine. I'm just going through and doing the resistors right now, and then I'm going to pull these 4 caps and test them out too. Okay, so I pretty much worked my way all the way through this board. Everything's done except the replacement transistor. These are the out of tolerance resistors. Was there 9 of them? 8 or 9 of them. Remember when I said it would be easy to substitute something in here? Well, I was wrong. But I did come up with one solution here. This is a 2SC2690A. I wanted to get one that was in this TO126 package, just because it needs to get mounted on the heat sink here. It's going to dissipate a fair amount of heat. So this will work. Problem with this one is the pinout is wrong. This is emitter collector base, not base collector emitter. So I have to swap the 2 leads. Either that or mount it upside down. Yeah, I can mount it upside down. That'll work. Yeah, I'll mount that upside down. And we'll, because this is not, yeah. And if this works well, these are audio frequency driver transistors anyway, and they're suited for application. A lot of transistors I have in TO126 are actually high voltage devices for driving CRTs, and it's not suitable for this, so that's why I had a hard time finding them. Okay, so I finished the second card. I went through and rebuilt everything and cleaned it up. Put the switch back together, soldered it back in. There was only one resistor that was out of tolerance, and that was on all of them. These were actually pretty good. So yeah, this is going well, this side anyway, this card. But before I put it back in, I want to deal with everything under here. I got one old cap here I'm going to replace, and I'm going to check, might shorten these wires up a bit, tidy this up. There's some resistors here I want to test. With transistor I need to test. This resistor here needs to be replaced, and I have to figure out why that resistor blew up. Is it because this cap's in backwards? It might be, I don't know. I'll have to check all this here, make sure it was done right, and we'll see what we can do with this before I put the card back in. This one here, yeah, that's going to work good, I think. This card is all finished and ready to go. Okay, we're making some progress here. Had this cap here. This is a 100 microfarad cap. It ran from this diode, the positive end of this diode, and it ran all the way over to this tube socket here, which is the preamplifier socket, and it was grounded here. So I removed all this and put a little 100 microfarad cap right here to this ground lug, so that is all self-contained and nicely isolated to this one little area instead of going across. Now, there was another cap here. This is an old, this is original 50 microfarad, 40 volts. And this is just on the power supply for the preamplifier. So I removed this and put this little 47 microfarad here, 35 volt. This is going to do the business now. Do a little bit of filtering on this red line that comes from the power supply, just for the preamplifier, just to give it a little bit of filtering there. And this one's an old one that's gone. Okay, tested this transistor's good. This resistor here tested out of spec, so I replaced it. It's 10K. Everything else tests fine in here. These resistors are good. These ones are good. This stack resistor was good. Now we get up to this point. Let's see here. This 22 ohm resistor, I'm still trying to, I was scratching my head. Why did this resistor blow out? If you look here on this schematic, it is actually pointed out to you here. This is the mute relay coil, and then there's a 250 microfarad, well it's a 220 now, cap here, and then the 22 ohm resistor. So this resistor should have never blown because it's in series with a cap. So there should be no DC through here. I couldn't figure out why would this resistor go up in smoke. And I'm looking at it here, and looking at it, and looking at it, and then it finally dawns on me. This wire was pinched underneath the lug, and I think somebody soldered. Let's have a look here. Can you see this? I'll zoom in. Where's my... This wire was caught under here, and I think it got shorted. Look at that. Yeah, the insulation's gone. So that wire was shorting here. That's why this resistor popped. And this is a power supply line. Comes off and goes to the driver board. Okay, it's power supply for the driver board. So we now know why this resistor blew. We can replace this, and we don't have to worry about it going again. So I'll get on that. Yeah, that's kind of interesting there, how that little fault caused some mayhem. So I'll get that fixed, and then this board can go back in after that because everything underneath here is done. This is the tone control board with the bass treble switches and the balance control. I was going to go through and verify these components are correct and clean some switches and then put this back. I'll probably reflow this. I've noticed there's a lot of crack solders on these boards because a lot of these joints just don't have enough solder on them. There's a potential short circuit waiting to happen here. Get rid of that. Alright, so on to the power supply and the other problems this thing has. So I removed this, and already this wire broke off. So I'll have to remember to reattach that. This just swings out of the way. These two caps are speaker output caps. I'm going to deal with them in a bit. I'm going to try to attack this power supply. So we got our transformer leads coming up. Secondary comes up and it goes to this lug and this lug. This is the bridge rectifier, believe it or not. It's a chassis mount device. It's got 4 pins. And then we have a red and black wire, which is the positive, and a red wire on this side, which is the negative. Positive 52, negative 52. So I'm just going to remove this all here. This is just all tacked in place, I believe. I don't know if my iron is hot enough for this. Okay, yeah, it's just tacked on. And let's remove this one. Okay. Get this out of the way. And this ground wire here is not needed anymore. I'll remove this. Just cut it. I'll just cut it. Great. Now, I drilled a hole in the chassis between the 4 filter cans so that we can mount the terminal strip. And I got a drilled for an M4 self-tapping screw. So I'll just put this in here and secure it. Might be, my hole is a little too small. Might have to drill it bigger. I know it's going. I'm just going to make sure it's not shorting anything. Okay. Screw this down. Tighten it up. Now I got a place to secure these caps. So I'm going to run this black wire back up to this ground lug. The center lug here is ground. I'm going to run the caps to that ground lug, and then I'm going to terminate this mess on here and this mess on here, and we're going to tidy this up a bit. So let me get back to you. I don't know if you want to do this on camera or not. Maybe I'll do it on camera. Why not? Let's see here. You know what? I'm tired of cleaning up this mess. Let's just cut. All right. Okay. Actually, I probably could have put a 3-lug strip on here. All right, and where's that cap? This was positive, that's right. Okay, we gotta clean this off. Gonna reuse these caps. They're brand new. I went on eBay, and they have these cap kits for these amplifiers. I don't know, people don't buy these things because you're paying for some of these greed. $75 US for a handful of caps that cost $5 at Mauser or DigiKey or someplace like that. You can get these caps for a lot less. Okay, so this one was positive. So it goes like this. Let me get some heat shrink on these leads to insulate them. Okay, just hang on. This one's going to go like this. And this is going to go like this. Okay. So fold this wire down. Okay. This one here we can fold this one back and deal with that one in a bit. So that's where that cap's going to rest. Not the most ideal location. So you got 120 volts right here. That should be okay. Now let's take this one. This is ground. We're going to add ground, a solder lug connection. Okay. Now our other cap here, we got 3 wires. Let's cut these ones off. 3 wires. Let's remove this. All right, now where am I going to put this cap? I could put it here. No, that's no good. That's because this is in the way. Yes. Okay, that goes there. So it's got to come this way. Okay, put it in like that. And these will secure here. Our last one. Okay. There's all our connections. Let's just dress this up. Okay, so that's good. Okay, and this one, might have to just melt this. Okay. This one's good. I can, okay, that fits. Okay, so everything's good. Nothing's in the way. I just want to bend this down. Okay, let's solder this one. Turn up my iron. Okay. A little too much solder. It's running down the... Okay. Let's clean this up. This one's ground. I can solder this. Okay. Okay, we can solder this one. Good. Oops, I did a little too soon. Okay, can leave this one here. This one can go. All right, now I can rework these two capacitors. They're using the old capacitor as terminals. That's no good. So I might have to add another terminal strip here somewhere. There's really no room because there's a big ground connection here, a big star ground. I can drill that rivet out and use that hole, but it's not really ideal spot. Like, it's not, you want that rivet to be like it's not loose now. I'll have to figure out something for these two caps. These ones are done. They're a lot more secure now. Let's see what we can do here. Okay, I made a decision here, executive decision. I'm going to drill out this rivet. This rivet holds down this cap, or it's half of what's holding down this cap. And then I'll replace it with the screw and nut. And we'll put a terminal strip right here, probably at this angle. And that'll eliminate this ground wire. And this resistor will go to the terminal strip. This resistor will go to the terminal strip. Two caps. And let's see here. I have a feeling this isn't wired properly, because this orange wire here, oh, what's this? That's not the output. This red and white wire is coming from the amplifier section, and it goes to this cap. I think this is still in circuit. All I think he did is he tacked another cap in series with the original cap, which isn't correct. And I think this is probably maybe the reason why he said it wasn't sounding very good. Well, we had one channel that was out, so we're only running on one channel. We were running on one channel, and then this one here, this orange wire goes back to the driver board. So I'm not sure what's going on here. This gray wire here and this gray and white, gray and red, these two wires are the wires that go to, let's see here, to the speaker output. So if I look here, gray and red, gray and white, this goes out to the relay, and the output for the speakers is right here. So that's our outputs, and they should be in series with the cap, but they're not. I don't see this here. So this is all messed up. I'm going to have to rip this all apart and redo it. So I'm going to drill this rivet out, put a terminal strip, and then we're going to rebuild that little circuit. Alright, so I got this all together, and looks like I got it. I think I got it wired in correctly this time. Yeah. And then I anchored these caps down with some silicone. Once that sets up, those caps will be rigid. and they won't be flopping around anymore. So everything's done here at power supply. The output caps are done. Gone through and I checked these resistor dividers, these stacks I guess you want to call them, and they seem fine. I want to pull out these 4 transistors and test them out of circuit, because testing them in circuit with these low value resistors really doesn't help me. You got to pull them out and have a good look at them. So I think I'm going to do that next. Pull these transistors out. Plus I got to clean the heatsink. It is pretty dirty. I just want to clean it up. So yes, I'll pull these out next. Alright, let's have a look at this amplifier. And see if it needs anything. Dirty inside. We got 2 stacked boards. This is broken off. That's unusual. I wonder if we could solder that back on and try. It'll ruin the paint though, that's the only thing. Looks like somebody's had this apart. Interesting. Let's remove. Oh, wow, these are long screws and standoffs. I don't expect there to be anything wrong with this thing, but we're just going to have a good look inside anyway. And then make sure it's all good, then we'll put it back together. Okay. Oh boy. Yeah, it's broken because somebody disconnected it and they pulled it out. All right. Well, it all looks good. Let's check these transistors. Maybe there's a bum one in there again. Fine. That one's fine, but this one's not fine. What's going on here? Got to Open base? No, open. There it is. Okay, let's check this one. That's not. There we go. Pinout on these transistors are okay. That one's good. That one's good. Okay, all 4 transistors are fine. I'm going to check over the soldering carefully, and then I am going to clean these boards so they look nice. Yeah, I'm going to redo some of these solder joints as well. Okay, I'm pretty much done with everything I need to do here as far as reworking the circuits. This is all finished. We need to power this up and test it. I removed these 4 transistors and I checked these resistors. They seem fine, but we're going to power this up. We're going to test the voltage drop across these dividers, and this board is finished, put back in. I'm missing the driver board here. I'm not going to do anything until this all checks out, and then I can reinstall that board. The tone controls and the balance have all been cleaned up and put back, and I think we're ready. So what we want to do is power this thing up. We don't have transistors and we don't have the driver board, so we've got incomplete circuits here, and so we should have really no drama while we plug this in. So here we go. And the cap's charged up and it drops to about 13 watts, which looks good. This aside, just gotta make sure I don't short anything out here, and then we can test some voltages. You can see this, I hope. Alright, so what do we have here? We should have positive, no, this is negative. Negative 54. This one here is positive 54. That's all correct. Let's see here. There's a number of supplies that come off and they go to different circuits. For example, 20 plus 23.5. A lot of those are under there and I can't measure them. Let's see here. Just want to see what this says. Zero there, okay. Zero. $42.1. Green and white striped wire goes to, where does that go to? It goes to the bias pot. Okay. Working around a camera here. That one is 0.118. That would be our bias voltage for the transistor. Minus 28.7. That's our center point, I believe. 12.87, and then this one should be negative 28.5. So far everything's checking out. Minus 28.8. Minus 28.6. Okay. This is all referenced to ground. So 41.69 minus. And that is the same as this one. 41.9. Seems like the resistors are all good. And that should be our 0. Okay. Everything looks good. So I think it's time to put transistors in and do some tests. Okay, let me explain a little bit about this bias adjustment. They have 4 trim pots here. This one, this one, this one, and this one. But remember, we've got 2 channels here. So this line here, this ground trace, is actually dividing the 2 amplifiers. And they have 2 trim pots for each amplifier. So it says here, adjust bias control for 25 milliamps and negative 26 volts. And then they point to this line here. So this should be minus 26 volts. And we should have 25 milliamps flowing through this transistor. Now, they got the same thing here. They have this connection here for this transistor. So I guess we have to measure. What I don't understand is if we adjust this trim pot, what sets up this trim pot? Oh, we'll get to that. But you can see here they have the terminal strip, and this big thick red wire comes from the power supply. Okay, that is our negative 52 volts on this A connection. A comes here, negative 52 volts, and it supplies both amplifiers. There is no positive. This is just one single-ended supply, negative 52 volts, which comes up to here. And then it's on these 2 spade lugs, and these are removable, so I can remove one or the other, and I can test the current through these transistors, because this one connects directly to the collector here, and this one connects directly to the collector here. So that's where we insert our ammeter, is right here at this point and this point for this channel and that channel. So let's get the transistors in. I cleaned up the heat sinks. These were the insulators that came with. So these are metal, believe it or not, and I think they're anodized. You can see in the end there's a metal showing through. So I'm not going to use these. I'm going to use sill pads, I believe. It would be a better choice for this. So I'm going to put these aside. I happen to think these are either aluminum or magnesium or something. They're quite rigid. Like, it's not, aluminum bends easy, but these don't. So these are going to get put aside, and we're going to use sill pads, reinstall the transistors, and then we'll set up the bias. Alright, something you have to really pay attention to when you're reassembling is these have these insulators dropped in these holes, and you can see that it's like a little donut, and it goes in the hole for the screw so that the screw cannot short out to the heatsink. See, the screw goes in there and that insulator keeps the two apart. Now I dropped one of these out of here and it disappeared on me, and thankfully I looked in the floor and here I found it again. So here, I'll put it back. If you lose one of these, you can cut a piece of heat shrink tubing to the right length and just drop it in the hole. All it has to be is big enough for, let's see here, where's the screw? For example, this one here. Just has to be big enough to allow the screw, and then it can, if it fits in the hole, you would just cut it off flush with the aluminum, and then you make your little donut and then just drop it in there, and that would insulate your screw from the aluminum. But we don't need to do that today because I found a little donut on the floor. If we don't lose it again, we'll put it in there, and then our seal pad. And then lastly our transistor. Make sure the legs are straight. Kind of a little bit wonky here, that's okay. And hopefully it drops in. It doesn't want to drop in. There we go. Okay. So flip this up. I want to inspect the socket from below, so just make sure it's in correctly. Looks like they're all good. Okay. Next, you want to just torque them all down evenly. Snug them down. You don't want to go crazy, because if you go crazy, you crush the sill pad and then it'll make contact. Okay, torque them all evenly, and then we go through with our voltmeter and check for continuity. Okay, checking for continuity. Okay, that's 0. That's not 0, that's 50 ohms. That's 33 ohms. 33. 50. It's looking good. Okay, so they're all insulated, and we should be able to power it up again. Okay, I got it all set up here. There's a lot going on here. We got a voltmeter connected across from ground to the speaker connection terminal for that channel. Let me see if I can. So I'm measuring on this red and white wire here. This one here. We want to measure it before the blocking capacitor, because measuring after does nothing for us. So we're going to put the voltmeter between this line and ground. And we'll do the same for the other channel. We'll put it on this white and black line to ground when we get to the other channel. Now I've broken the connection here from the B-, and I also disconnected the other amplifier because we don't need both amplifiers on for this adjustment. So power comes in on this red wire again. It goes to these two terminals, and then I have an ammeter connected between here, the wire, and the lug. And that's this one here. It's on the 300 milliamp scale right now, but we'll turn that up when we need it to get to 25 milliamps. we'll get the resolution we need. And all we got to do now is just plug it in. Let me see if I can get the cord here. And here we go. Okay. So on a 300 milliamp scale, we got about 60, 70 milliamps here. This is not good. And we got 28 volts. So we have to adjust these two trim pots to bring everything back in line. So where do we go here? We got to turn this one first. Turn this one down. Turn it down until we see 26 volts and 25 milliamps. So we got our 26 volts, and that's completely down. Okay, so we got to turn the other one down too. We are still at above 50 milliamps. That one raises it, this one lowers. So we still have a problem with the amplifier. I think we might have a bad transistor in here. So they both turn down. As far as they go, if I go up to the 30 milliamp scale, okay, we are on 30 milliamp scale. So we're only at 15 milliamps now. What's going on here? The meter's not reading correctly. Let's turn these up. Turn up the other one. Okay, so we're at 24 milliamps and we're at 25 milliamps right now, and we are right on 26 volts. So I'm going to leave it there. That should be correct. And our idling consumption is 15 watts. Alright, let's do the other channel. Okay, both meters connected to the other channel. Let's turn it on. And we are up around 27 milliamps and 28.7 volts. So we got to adjust these two over here, these two. If you can see this. These two here. We need to turn the current down and drop the voltage as well. So we got to turn both of these, I believe. So there's our 25 milliamps. Let's go farther. Let's take it down to 23 and turn this one up. And back at 25. A little bit too high. 25 milliamps right there. And our voltage came in place. Perfect. That's all there is to a bias adjustment. Give or take, this one, turning both of these affect the meters, so you got to get the balance between the two. Yeah. All right. So Consumption's now down around 14.9. Now if I pull all my meters off and connect up both amplifiers, we should see about, let's see what our consumption goes up to this time. There we go. Okay, about 16 watts or so. That's good. That's not going to overheat or anything with that big heatsink. So we're good. I'm going to reinstall the driver and let's see if we can get a signal through it. Alright, so here it is with the driver board installed. I got it all wired back in, but then I realized I made a mistake and I misguided you guys, so I'm going to correct it right here and now. Now, what I did is I followed the instructions on this sheet. Let me get rid of some of this. And it says right up here, adjust bias control for 25 milliamps and negative 26 volts. That's all fine and dandy, assuming our power supply is delivering negative 52 volts. But this should be exactly half of this, and I didn't do that. I set this to 26 and I ignored that. So what I'm going to have to do is go back and, well, we can do it right now. We can measure the voltage of the, let's measure the voltage of the power supply. And then we have to do exactly half of that. So let's plug it in. There we go. And let's measure our voltage here. So we should have negative 54.2. So yeah, we weren't far out. And this number will change as the bias controls are adjusted. The more bias you give the transistors, the harder they turn on, and the more current that flows through them, this voltage will drop as the power supply gets loaded. Where'd it go? Yeah, we're at 54.2. So I should have actually adjusted that center point to 27 volts instead of 26 volts. I can go back and redo that. It's not a big deal. Okay, so we're ready to do a power up test and put some signals through it, but we got a few obstacles to overcome first. We have, let's see here, this is our phono preamp. That's not installed. It's still empty. We're going to leave that out for now. And this here is your AVC printed circuit. That's that big board with the photocell and looks like a little relay, but it's not. Anyways, this circuit's in place. This circuit's in place. This circuit's in place. But this circuit is missing. This is the volume control assembly, and it plugs into this J4. And from what I can tell, it's got a couple of 25K pots, and then it's got some a Biden moment here. I gotta think. It's got some tone control stuff going on here, like it's like a low volume bass. So I guess if you put that on, it boosts the bass when you got low volume. And yeah, we don't need to recreate this exactly, but we still need to get a signal to flow through J4. So we have a signal coming into J4 and a signal coming out of J4, and this is the missing piece right here, this volume pot. So I can tack something in circuit, a couple 25K pots. I can figure out, let's see here, yeah, it's just simple. It's just attenuating the volume circuit, and that will get the signal going through to the end, and then we can start feeding in tones and we can see how this thing runs. Another thing is we have our muting relay. Here it is. I pulled the cover off, had a look at it. Looks fine. I put power to it, pulls in. Probably needs the contacts to be cleaned, but I think the relay is working fine. He did supply me with a replacement, which we'll probably put in because it was his request. We'll give this one back to him. But I'm looking at this schematic and I'm having a struggling trying to figure out how this relay coil is powered. There's a big black line here which is our ground, and that goes up to the center pin of this connector, and that is, I'll flip this thing around, it's kind of heavy. Okay, you can see down here in the corner, here's the 8 ohm output and mute connector. So we have 2 connectors of 3 pins, and if I look at this, there's a key on pin 1, so pin 1 is keyed. Right here is pin 1. So I got pin 1, 1, 2, 3, 4, 5, 6. Looking at the circuit here, I don't know what supplies power for this. This side here, this pin 1, 3, and 5, that's our speakers coming out, speaker output, and a ground for them. On the other side, we have a ground in the center, and we have both coil windings on pins 2 and 6. So where's this power coming from for the mute relays? I don't know. I think it's something that comes from somewhere else. Doesn't seem to be any provision for it. So, but that, I don't need to mute it to test. I can mute it, but all the muting does is when the relay, you put power to the relay, it clicks the relay. See, here's the speaker coming through, going through the contacts out to the speakers. And when you click power to the relay, it pulls these contacts in and grounds these 2. It grounds them so that the speakers are muted, and it redirects the speaker output to these 2 5 ohm resistors. So it's not open circuit. There's always a load on it, and that'll shut it up and make it silent. And then when you take the power off the relay, these contacts go back to rest, and signal flows through again. So I don't need to even put this relay in circuit to have it working right now. I can just leave it out and we'll test it later. But like I said, this relay is working fine. Probably like it needs a clean for sure. Okay, just hang on here. I'm going to unplug. I smell something getting hot. I just suspect it's just resistors from underneath, but I just want to make sure that nothing's burning up here. Everything's fine. I think it's these resistor strings that are down underneath here, the voltage dividers that are getting a little warm, starting to put a little current through them. So let's go back to testing. Alright, so we have everything set up here to do power test, but I just want to make sure we got a signal through this thing because I haven't seen it working yet. I got an 8 ohm load hooked up here to the outputs. I don't know which is which, it doesn't really matter, left or right. Stereo switch is set to stereo. The AVC is set on. Relays out, that doesn't matter. No preamplifier. And I have on this little probe here, I got like 100 millivolt signal, 1000 hertz tone. I'm going to feed it into this volume control jack. Let's plug it in and let's see what we have on the scope. Okay, if I can do this, okay, here, try it again. Oh, there's a signal on the top trace and the bottom trace. Okay, so we got to increase the volume here. Turn it up to 300 millivolts. Now let's take a look at what we can do with this amplifier. It's working, both channels. We have this channel and this channel. Is quieter. I got the wrong scale here. Okay. Just want to see what we can do for clipping. Let's trigger off the trigger off channel 2. Okay. Yeah, it gets quite warm. Alright, let's turn this thing up, see what it can do. Alright, there's our clipping. Both top and bottom, back it off a bit. And we have 9.8 volts RMS on that channel. Turn it down. It's not going to be a big powerhouse, that's for sure. Okay, let's turn this down. Let's try the other channel. This side got a little warm, not even warm enough to talk about. Okay, start turning it up until we get our clipping. There we go. The clipping, let's back it off. Right about there. At 9.86 volts RMS. Pretty much good. Distortion free. That's what we like. So far so good. Here's both channels. This second channel is a little low, so I'm going to increase it a bit. Wrong way. There we go. Oh, a little bit of a phase difference between the two. Just want to get these equal. I think pretty close there. Turn this down. It's not too bad. This thing doesn't even get warm at full power, barely. Consuming about 80 some watts at full power on both channels. You can see a little bit of this phase difference that I was talking about. Here's the mono stereo switch is set to stereo right now, and I'm feeding the exact same signal into both channels. But watch when I flip to mono. See how the bottom tray shifts ahead in time, and then when I shift it to stereo, it seems to be lagging. Just wondering what's causing that. Gone through the circuits, everything should be equal and same. Here's the treble control, turning it up and down. Bass control. It's a step attenuator type setup. Okay, so I'm feeding about, let's turn this down, about 20 millivolt signal in here, and I'm bridging both channels so they're both feeding the same. Got the amplifier installed and connected. We should have the signal coming from here, going to the amplifier, going through the AVC circuit, and then coming back out in this volume control. So if we scope these bottom two pins, we should have a signal on them. We've got a slight signal there. We've got a big signal there. And a big signal there. Okay, I think that's our 2 channels. So I think we're good. Okay, so one last test here. I have these jumpered together, the 2 inputs for the phono, and I'm going to feed it a signal here. Start with about 5 millivolts. I'm just going to start that up. You can see it on the screen. Now this here is jumpered. Whatever comes out of this amplifier goes straight back into this amplifier. So let's turn up the volume on our signal generator and see if we can get I'm going to have to make an adjustment. Quite a bit lower on the 2nd channel. So let's tweak this. Don't know whether I should turn this one down or turn the other one up. Pot's a little dirty too. Oh, that was turned right up. Okay, so let's turn this one. They're both maxed out. Let's turn them down until they're equal. Right about there. Yes, okay, so let's continue going up. Here's our clipping. And it looks good. Probably what I'll do is I'll put a little sticker over here just to, because these are very touchy and I don't want them moving. So we're pretty much done. Okay, so it's all finished, ready to go back to the owner. I'm sure he'll be happy to see it again. Yeah, this is a fun one to work on. There's a lot going on. There's quite a few things wrong. We had a dead transistor in the driver, which would have made one channel completely dead. Thankfully, these 4 germanium power transistors were good, because that could get expensive replacing those. But they're good, and just going to let it go. And he did a recap on it. For the most part, it was good, except for that area where we fixed it up, power supply. He's got 2 relays here. I think he purchased another one because this one has a smashed lid. And it's still working. I'm going to give it back to him, but I'm going to replace this one just because we have it, and then we can say it's there. It sits in a socket, and then it's got a spring retainer, and that's going to keep that locked in. That can go back to him, and that's it for this one. Thanks for watching, and hope to see you in the next one. Take care.